we're going to compare functions, and basically it's going to entail using the rate of change. Now, the last lesson we looked at whether it was linear or nonlinear, and that had to deal with a lot of basically looking at the rate of change of the functions. And some people were able to find some shortcuts around it, but this is the lesson where you're still going to have to come back and say, hey, I need the rate of change to see which is changing faster. And we'll get into that later about what that means. What makes it hard is I might give you one function that's a graph. I might give you another that's an XY table, and still yet another it's just a set of ordered pairs, maybe an equation, something like this, y equals 2x plus 3, or maybe just a verbal description where it's just a bunch of sentences that are giving you some information in there. So that's what's going to make it difficult. The normal thing is where they will give you two different functions and they're going to ask a basic question. Here's Katie's race time and here's Kylie's race time. They're given in two different formats, but they're both functions. And here's the question: who ran faster? So how do we proceed with that? Let me get my pen set up so we can talk about that. Basically, we start out with trying to look at what is on this graph. Is speed basically, time and distance? Well, this graph has seconds and meters, right? So the meters are the y value right here, and the seconds is the x value. So that's kind of like measuring the change of time over the change of distance, change of distance over the change of time. That sounds like slope to me. Or we just learned in the last lesson the rate of change is slope. So if we could just find the slope of this line, and now I'm just going to call it the rate of change here more often, we'd be able to know how fast Katie's race is, or what's her time. How do we do that? We need to basically find 2 points. So here's a point, and then we can use this point here with this one, or we could use this point here and this one. It doesn't matter, just use 2 of them. And then we're going to use this formula, and this has to be memorized: y2 minus y1 over x2 minus x1. I'm going to choose, let's see, these 2 points, 0, 0, 4, 12. And the reason is I didn't choose here is that I didn't know if it was 1, 3 or 1, 3.5. I didn't know if this one was exactly 2, 6. Maybe it is, but I just wasn't sure. These 2 were very clear. So that's the 2 I used. I plugged them into my equation, and we should have confidence that 12 minus 0 and 4 minus 0 equals 12 divided by 4, and that's where the 3 came from. So Katie's rate of change is 3 meters per second. If you're wondering how to label this rate of change, you just use your values off the y-axis and x-axis, and it becomes 3 meters per second. So there's Katie's race. We know she was running at 3 meters per second. Now we've got to turn our attention to Kylie's race. This is totally different. So what's her speed? What's her rate of change? How do we find the rate of change? Very similar. We're going to use that same formula again. We choose 2 points, any 2 points, and we're going to plug them in and solve. So I just chose these 2 randomly. It didn't have to be these 2. You can choose 2 different points, and in fact I encourage you to stop the video right now. You go get the slope on this one, the rate of change. You go get me the rate of change by using your 2 points, and let's see if we get the same thing. Okay, this is what I got. I used those 2 points, plugged them in, I got positive 2. So Kylie's rate of change is 2 meters per second. Which one's bigger, 3 or 2? Obviously, Katie's running faster because it's 3 meters per second, and Kylie's only running 2 meters per second, so Katie can run faster. That's the answer. That's the whole point of this problem. And people are going right now, I don't get it. Okay, let's move on to a different one and see if this helps. Next situation: 2 brothers have agreed to pull up their, to basically, I meant to say pool. Let me fix that right now. To pull up their savings. You know, like they're going to put it all into one pot, and they're going to put their money together, and they're going to get this dream TV. They're wanting to save up to buy a new TV that costs a lot of money. They set aside a certain amount of money each month to save up for the TV. How much does each brother save each month? Well, you've got Billy right here, and you've got Bobby right here. What it comes down to is that both of them are saving up money each month, and it's being shown in different ways. Here we have a function graph, a graph of this relationship of how much he's saving each month. And Billy, we're giving an equation. So that's the difference. And that's going to bug me. It's going to say pool every single time. So just when you see that, please understand it should be pool, P-O-O-L. Let's go through and find Billy's savings first. How can we find out how much each brother saves each month? Find the rate of change. So that's the same thing as finding the slope. And I'd say if we worked with Billy instead of Bobby's, if we work with Billy's, that'll be easier. So let's just kind of isolate Billy's rate of change, and here's what was given to us. Billy's savings are represented by y equals 50x. The y represents his total savings. So this y is how much he's got saved up so far. And x represents the number of months he's saved so far. What's the rate of change known as? Slope. What's the slope of this equation, guys? 50. It's the number in front of x, the coefficient in front of x. So linear equations have a slope in their equation. It's the number in front of x. So basically, it's 50. So Billy's rate of change is 50. That's great. What does it mean? Let's build a function table just so I can show you what it means. It's important to know what it means. Here's an x and y. X represents the number of months, so right above x, I'm saying this column will represent the number of months. What's y represent? Y represents total savings. So if I plug a 0 in, I know that he's got 0 money saved. What's that mean? It means that I plugged, say this 50x, here's the equation, the x was 0, so 0 times 50 is 0. That's how. And what's that mean? It means at 0 months, he has saved 0 money. So if I plug just 2 in, I can plug any number in. What's 2 times 50? 100. So what does it mean? At 2 months, he saved $100. So if he saved up for 6 months, if I just plugged in 6, that's 6 times 50, it's $300. That's how we got the 300. It means at 6 months, he's got $300 saved. So Billy's rate of change is 50, okay? It's 50x. X is the number of months. So what does it literally mean? What does the rate of change really mean? It's telling us how fast he's saving every month. Plug in 1 for x. For every increase of 1x, you know, of 1 month, how much money did Billy save? $50. After 1 month, he saved $50. After 2 months, he saved $100. After 3 months, he saved $150. And it just keeps going up by $50 each month. That's what the rate of change is telling us. And the original question was, how much does each brother, wow, I see another typo in there too. How much does each brother save each month? So this brother is saving $50 per month because that's his rock. That's his rate of change. Okay, now we just got to do the same with Bobby's rate of change. And this one's a little bit easier because it's a graph. So we could use 2 methods. We could graph it, or we could take 2 points from the graph and use the slope formula. We're going to do both. I chose these 2 points right here. To get from the bottom point to the top point, I had to go up 10 points, or 10 units. So that's a positive gain. And then I've got to go to the right 2 units. So that's a positive gain. So 10 divided by 2 is 5. Guess what my rate of change is? 5. The other method is I could take 2 points, and I like these 2 points because they're nice and easy. This is 210. This is 0, 0. Plug it into this formula down here. 10 minus 0 is on top. That's my y's. 2 minus 0 is my x's. 10 minus 0 is 10. 2 minus 0 is 2. 10 divided by 2 is 5. So no matter what, we know the rate of change is 5. What does it mean? Well, use the labels on the graph to piece it together. Um, Basically, we're going to get $5 for every 1 month. So if I go up 5 and go over 1, we just got $5 for 1 month saving. So this brother's literally going to be saving $5 per month. Let's go back to the original question with it now. Whoops. Hang on just a second here while I pause. There we go. I got my screenshots fixed there. Basically, though, we just found out that Bobby's saving $5 per month. Billy's saving $50 per month. He just asked us how much does each brother save each month. Now we know. If it said which brother is saving more, we'd say Billy's saving more. So it looks like Billy's a lot more committed to the TV, or maybe he's just an older brother or something like that, and Bobby's younger. Those details are not important because all that it asked us was how much did each brother save each month. And we did this by finding the rate of change. The key is this: no matter what, you have to find out how fast it's happening. That's what the rate of change is going to tell you every time. So in a situation like this, the fact that we were looking at a monthly rate, how much is happening each month, we needed to find out how much is being saved each month. The rate of change, or the slope of that function, will tell you that. It takes practice. It's time to basically just roll up your sleeves and dive straight in at this point. We've got a number of different scenarios for you. Work in groups, ask me questions, and let's have some success at this today.